This is video 1.3.1, radicals, and the goal is to be able to simplify radical expressions. So first of all, let's take a look at what a radical expression is. These three are radical expressions. A radical expression is an expression in math that has a radical symbol, and the radical is a square root, okay? So the radical expression actually could have a number out in front, like 2 square roots of 160, or it could have a big number on the bottom. It could be all over 5. But as long as there's a square root in there somewhere, that's considered a radical expression. Why is it important to simplify? Because it is helpful to estimating answers. That was the ultimate reason for why we learned how to simplify radical expressions, and I found ways to do it by keeping the value the same but making it a simpler looking number. What's interesting though is it has become somewhat obsolete to estimate radicals. Back in the day, they used to have to estimate things in their head because we didn't have calculators nearby. So now we have calculators, so we can just punch it in. But what's interesting is on standardized tests, whether they be ACTs or MCAs, they expect you to be able to make radical expressions proper when giving answers. And so this simplifying process that you're going to learn is actually going to make the answers proper, and that's the answer you would see on a multiple choice standardized test. And that's why it's important right now. So we have calculators. We could punch in both of the questions that we see here and here. We could just punch them into our calculator and get a quick answer. This one, once we know y and x, we could punch into our calculator. That's great, but can we simplify it right now before we actually use our calculator? And that's what you're going to learn in this video. So example number 1. The first thing that you need to know is that radical can be separated. So we could separate the square root of 80. The square root of 80 can be separated, but only with multiplication and division. So we could change this. This is equivalent to the square root of, well, we know 40 times 2 is equal to 80. So this is the same as the square root of 40 times the square root of 2. Those are equivalent expressions. Also equal to this is the square root of 20 times the square root of 4. Those are equivalent. This is a process of associativeness, so we can kind of rearrange things and separate multiplication. But what square root of 80 is not equal to is the square root of 79 plus the square root of 1. Hopefully you can see where that would head. If we kept separating it with addition, we'd have a bunch of square roots of 1 adding up. We'd have 80 of them, and we would eventually say that the square root of 80 equals 80. And we know that's not true, because square root of 80 is asking what times itself will equal 80, and estimating in our heads, we can kind of see that's about 9, because the square root of 81 is 9 exactly. So how do we simplify this? We're going to use this idea of separating it. And what we're going to do is we're going to look for some perfect squares in here. So we're going to talk about how we can use this idea of breaking it up into a product, like 40 times 2, and using that to help us find out what we can actually take the square root of. Because if you notice real quick right here, the square root of 4 is just 2. That's a nice number. So this could already be written as 2 times square root of 20. Those are equivalent to square root of 80. Okay, we did some of the operations that we could. But again, we can't take the square root of 20 without separating it further. So here's the process we're going to take to simplify square roots. We're going to prime factorize 80. So that means we're going to find prime numbers that go into 80, like 2 times 40. So 2 is done. There's no other way to get 2 other than 2 times 1. 40 can be separated further. We can do 5 times 8. Again, 5 is prime, so it's done. But 8 can be separated further. Well, 8 can be written as 2 times 4. And 4 can be written as 2 times 2. So 80 is really 2 times 5 times 2 times 2 times 2 times 2. 4 2s and a 5. So that's the same thing as 80. So we could separate this into multiple ones, but we actually want perfect squares. Since 2 times 2 is 4, we can really write this as 4 times 5. That's the 5 here. And the 4s are nice because when I add in the square roots back in, remember we're taking the square root of 80, I know square root of 4 is 2. And I know the next square root of 4 is also 2 times 5. So the answer is 4 times square root of 5. And we just write that as 4 square root of 5. We don't actually write the multiplication symbol. This is the simplified answer for the square root of 80. So notice what we did, and hopefully you can notice some generalizations to make your life a little bit easier. All these pairs of 2's, like these two 2's right here, made a perfect square that ended up turning into a 2. So you might be able to jump some steps here eventually once you get good at this. But your goal is to find things that you can take the square root of, like 4, and then actually take the square root of them. You're trying to get things out of the square root. This becomes easier to estimate in our head because square root of 5 we know is a little bit bigger than 2, and that number is being multiplied by 4, so we could say this answer is a little bit bigger than 8. Okay, and that's what this is allowing us to do. So let's take a look at the next example here. So we're prime factorizing to break up the 140, but the x squared is just going to be separate, and the y to the third is going to be separate as well. So why don't we do that to start with? We're going to think of this as square root of 140 times the square root of x squared times the square root of y to the third. Hopefully you know that the square root of x squared is just x. So that's already pretty simple to simplify. We'll talk about y to the third in a minute, but let's practice what we just did in the last video. So we're going to take 140 and we're going to separate it in prime factorization. We know it's 7 times 20. I just pick something I know and multiplies to 140. 20 is 2 times 10. And 10 is 2 times 5. And I'm at the end because I have a prime factorization. Notice again you have a pair of 2's, which makes 4. 2 times 2 is 4. So we really have square root of 4 times the square root of 7 times the square root of 5. That's the same as the square root of 140. But since we know square root of 4 is 2, we take that and make it a 2 square roots of, and we're actually going to put these back together with 7 and 5 because we want to keep it simple and write as little as we can, and that's actually 30 square root of 35. So we're going to rewrite that. So square root of 140 becomes 2 square roots of 35. The x squared became x, and the square root of y to the third, well, remember y to the third means y times y times y. Do you see the y squared that's forming here? It's really square root of y squared times square root of y. And then the y squared again, we know that the y squared is just y times square root of y. So what we do is we take that y out. So taking a look at everything that we have to kind of reorganize, the square root of 140 became 2 square roots of 35. The square root of x squared became x. And the square root of y to the third becomes y square roots of y. So we're going to put it all back together and get our final result. So we're going to have 2 square roots of 35 times x times y square root of y. Again, we want to simplify this. So again, some of this you could probably do in your head eventually. All the non-square root stuff is going to come up front, so 2xy. And all the square roots are going to go in single square roots, so it's going to be 35y on the inside. This is a simplified proper square root answer. So it's equivalent. This is the exact same answer, exact same value as this for any x or y. Of course, y can't be negative, or you can't take the square root of it. So that works for any x or y where y is not negative. And it is equivalent, and that's the whole goal, to find equivalent simplified expressions that are proper. We'll talk more about proper in the next video, but let's take a look at this last example. Square root of 25 over square root of 120. So we have this fraction, and of course, just like any math, you want to simplify fractions as best you can. You can take 2 routes here. We can simplify the inside and then simplify the radical. So let's simplify the inside. 25 over 120. Remember, to simplify fractions, you divide top and bottom by the same thing, and we should at least see that 5 goes into top and bottom. So this is equivalent to square root of 5 over, let's see, 5 goes into 120, 24 times. So now I really have square root of 5 over 24. So now I'm going to simplify the radical, and this is the next property of radicals you need to know, is that you can separate top and bottom. You'll get the same value if you take the square root of the whole thing or the square root of the quotient separately. Square root of 5, that can't be simplified, but 24 can be factorized just like we did in the previous example. So we can rewrite it as 2 times 12, or 12 can be rewritten as 2 times 6, and again 2 and 3. So really square root of 24 is square root of 4 times square root of 2 times square root of 3. Those are my 4 factors. Square root of 4 is nice because it becomes 2, and square root of 2 times square root of 3 becomes square root of 6. That cannot be simplified any further. So 24 on the bottom can be written as 2 square roots of 6. So now I have square root of 5 over 2 square roots of 6. Now the final step that's important to know, this is very simplified, but it's actually not done yet because one of the things with math people is they also do not like radicals in the denominator. Just like we don't like decimals in our fractions, this is a decimal within our fraction because square root of 6 is a not nice number. So we're going to get everything that's radical up to the top. We're not going to be able to eliminate the decimals completely, but we're definitely going to get rid of them and bring them to the top. So the way we do that is we don't want to change the value. So just like we did a legal move up here by dividing by 5 top and bottom, we're going to do a legal move that doesn't change the value of the fraction, it just changes the look. And we're going to times by a clever form of 1. You'll see why I'm doing this once I write it out. So I chose square root of 6 because it allows me to change the value, without changing the value, but it also gives me a pair of 6's. And that pair of 6's will create a square root of 36 in the denominator, because 6 times 6 is 36. The 2 will still be there from this 2. But square root of 36 is a nice number. That's 6. So really it becomes 2 times 6. That's my denominator. My numerator is going to be square root of 5 times square root of 6, which both of those cannot be simplified further, so it's just going to be square root of 30 on top. I'm going to multiply those. And remember on bottom we had 2 times 6. So it's really square root of 30 over 2 times 6. So the final answer is square root of 30 over 12. That's your simplified and proper answer. So that last step that we just did of multiplying by the square root of 6 over the square root of 6, we're going to talk more about that in class, but I just want to throw it out there now. Bring in your questions, remember. Your goal is to bring in questions into class that perplex you and don't make sense to you, that you want to understand better. So be sure to bring in those questions. You're going to try an example that's a problem more like example number 2. So see if you can repeat similar process as you saw in example number 2 and example 1, which had all numbers. See if you can simplify this radical and bring in your answers to class tomorrow, and bring in all those questions that you may have about this video.